to do that. So we are going to discuss these things, that what exactly is industrialization and what does it entail, and can India ever catch up? So Abhijit, starting with the first question itself, what exactly do we mean by industrialization? What is this phenomenon all about?
Okay. So, see, the thing is, industrialization is, for me, and I think for most anthropologists, is the application of chemical energy to the production process, right? And many people confuse this with scale. You can have potters making pottery, you can have hundreds of thousands of people together, like the Ming Imperial Porcelain Factory, or you can have hundreds of thousands of slaves working off in a coal mine. That doesn't make it industry. And the problem in India is several historians like Irfan Habib, Romila Thapar, and co. They claim that scale is industry. Scale is not industry. Industry and industrialization, very specifically, start with the use of coal energy to the industry, to a production process, and then they move on to other fossil fuels, so diesel, petrol, and things like that. And now, of course, you have nuclear energy. So it's basically what it does. For example, the earliest use of coal was to pump water out of coal shafts. And it was the most logical thing to do because you're producing the coal out there. And they discovered that there was this water pump, because one of the things in England when you are digging for coal is, because it's so rainy, the water tends to accumulate, and you needed to keep draining these tunnels of water so that the miners could extract the coal. And what would happen is that you had they discovered this coal engine which would then suck the water out through vacuum and pressure. uh, and it was fantastic because for a human being, it required them to keep taking buckets out, keep bucketing things out. Whereas here, what you had was a pipe which was sucking all the water out. And it was fantastic because it did it in a much, much more efficient way. So the efficiency increases manifold because, see, your total energy, if you look at it mathematically, the total energy available on Earth for a normal physical process as opposed to a chemical process, which is to say a human being doing things, is the sun radiates a certain amount of energy onto Earth. The Earth processes it and it produces crops which you eat. In that process, a lot of energy is lost. Then when you eat, only part of the energy gets absorbed into your body. Most of it gets lost. And then there is only that amount of energy that you can expend on a physical process that you do, like bucketing water out or lifting a rock. Whereas with chemical energy, the loss is much, much less. It's focused to that particular point, like, say, a coal engine or a coal water removal machine. And the benefits are extraordinary. If you want to do a simple experiment, what I'd suggest is, if your car gets stuck in a pothole, to push it out, you will require at least 10 to 15 human beings to start pushing it. On the other hand, it doesn't matter if you've even got a Maruti 800, a little underpowered car. You push it bumper to bumper and push that car back. It'll happen like that in like 2 seconds. That is the difference between chemical energy and physical energy. And that it is the application of that which is called industrialization.